There's been a surge in news about solar storms worldwide, particularly lately. Well, what exactly is a solar storm? Hey there! Hello, young scientist! Welcome back to our channel. Today, we're blasting off into the electrifying world of solar storms. Buckle up, because this cosmic roller coaster is about to take you on a wild ride through the sun's explosive antics. But first, hit that like button and subscribe for more such content. Let's invite Samuel to explain what exactly is a solar storm and why does it happen.
Thanks, mate. As someone who is an expert in solar science, allow me to guide you through the rest of the session. Our sun is like a fiery disco ball, constantly grooving and shaking with magnetic energy. Sometimes things get a little too wild on the dance floor, and bam, we get a solar storm. These cosmic explosions, the solar storms, are often triggered by magnetic disturbances on the sun's surface, called sunspots. Sunspots are areas on the sun's photosphere, its visible surface, that appear darker than the surrounding areas. They're caused by intense magnetic activity, and they often lead to other solar phenomena like solar flares and coronal mass ejections, CMEs. Typically, sunspots last for a few days to a few weeks. However, some larger and more complex sunspots can stick around for several weeks or even months before eventually dissipating. Geomagnetic storms that can occur as a result of these solar storms in Earth can induce electric currents in power transmission lines and pipelines, potentially causing disruptions to electrical grids and damaging transformers. In severe cases, widespread power outages can occur. Solar storms can interfere with radio communications, satellite operations, and GPS signals. This can impact a wide range of services, including telecommunications, navigation, aviation, and emergency response systems. Solar storms can elevate levels of radiation in Earth's upper atmosphere, posing risks to astronauts, airline crews, and passengers flying at high altitudes. In extreme cases, elevated radiation levels may prompt airlines to reroute flights to lower latitudes to minimize exposure. One of the most famous solar storms in history is the infamous Carrington event on September 1st, 1859. It was a quiet day, much like any other, when suddenly the sun unleashes a massive solar flare, observed by British astronomer Richard Carrington. This event, now known as the Carrington event, marks the beginning of an extraordinary cosmic spectacle. It disrupted our planet's magnetic field, creating intense geomagnetic storms in the process. The impact of the Carrington event was felt around the globe. Telegraph operators across the world witnessed sparks flying from their equipment, and in some cases, telegraph lines themselves caught fire. Solar storms operate on a cosmic clock known as the solar cycle, which spans roughly 11 years. During this cycle, the sun goes through periods of high and low activity, with solar storms reaching their peak around solar maximum. The exact mechanisms behind the sun's magnetic cycle are still the subject of ongoing research, but scientists believe that it's driven by the convective motion of plasma within the sun's interior. During the first half of the solar cycle, known as solar minimum, the sun's magnetic field is relatively simple, with a weak overall intensity. But as the cycle progresses, magnetic activity ramps up. At solar maximum, which occurs roughly halfway through the cycle, the sun's magnetic field reaches its peak intensity, with numerous sunspots and intense magnetic activity across the sun's surface. This is when solar activity is at its most intense and when solar storm generally occurs. Based on the typical 11-year solar cycle, the next solar maximum is expected to occur sometime around, well, can you guess? It's in 2025 to 2026. Now, here's a question for you. What factors influence the timing and intensity of solar maximum? Drop your thoughts in the comments below and let's unravel the mysteries of the sun together. All right, cosmic explorers, we've reached the end of our solar journey. But before we sign off, let's discuss how to be prepared for this cosmic event. Infrastructure resilience. Strengthen critical infrastructure, such as power grids and telecommunications networks, to withstand potential impacts from solar storms. Secondly, make communication plans. Develop communication plans with family members, colleagues, and emergency services in case of disruptions to traditional communication networks. Consider alternative methods of communication, such as satellite phones or two-way radios. Finally, emergency supplies. Keep a supply of emergency essentials on hand, including food, water, medications, and first aid supplies. In the event of a prolonged power outage or disruption to infrastructure, having these supplies readily available can be crucial. This includes cash supply, as if the power outage gets prolonged, there won't be any functional FPUS machine or ATMs.
And there you have it, fellow space travelers, a cosmic crash course in solar storms that's sure to leave you starry-eyed. Thanks for joining us on this stellar adventure, and until next time, keep your eyes on the skies and stay curious.
Thank you so much for watching. I hope this video helps each and every one of you out there. We hope you come and visit our channel for more helpful videos. Your support means the world to us, and if we've made your day better, please give us a shout through comments, like and subscribe. We truly appreciate every single one of you. Take care, stay awesome, and we'll see you in the next video.